A lot of people don't realize is the importance of what's done during the week to enable the car to roll off the trailer fast, because as sanctioning bodies reduce testing, you have to hit the track fast and you have to learn as much as you can. That same requirement is in today's production vehicles. In order to get cars to market quickly, you need to learn quickly and adapt quickly. So we've taken a lot of the learnings, a lot of the tools from our racing program and incorporated them into the production program. So whether it's vehicle simulation or aerodynamics, those learnings on the racetrack are integral to what we're doing in the production world.
Computational fluid dynamics, otherwise known as CFD, is performed by our Corvette group to aid us in aerodynamic development and making aerodynamic development decisions in conjunction with wind tunnel testing and track testing. We have software tools for different aspects of the car, for aerodynamics, for engine performance, for structural analysis, tire modeling, and a wide array of software tools. We have an ongoing development operation where we're continually developing the car for the next race, for the next test, for next year. And that's one of the things that is unique about our racing operation, is that the advanced engineering tools stay in the program, stay active for the course of the race program.
What we have here is one of our C6 GT chassis. This is the production aluminum chassis, the same chassis that's used in the production ZR1. We do make a few modifications to the chassis to accommodate the race suspension, the race body work, but it's very limited.
Corvette Racing is a great platform for us to build on and improve the production vehicle. We refer to it as cascade engineering. We take the production car and through racing make it even a better car. It's a great car to start with, we make it even better, so when the next generation Corvette hits the street, the learnings from the race program are in that car. We saw that in the C6 with the flush mounted headlights that were a requirement of racing, larger front opening for airflow to the brakes. Those are all things that we learned on the racetrack that made the street car better.
Here in the design office, we are assigned a variety of tasks on a regular basis, and in particular with the Corvette program, it'll vary from race to race. In one particular instance, they were trying to find a faster way to do repairs or make adjustments on the car with air hoses feeding the air intake system. This is a rapid prototype part that came about as an idea directly from the race team. It is a two-piece plastic part that came off of our rapid prototype machine. And it's just a quarter-turn fastener, which means a Phillips head screwdriver turning at 90 degrees will now pop this apart. Now, instead of having to fight a hose clamp, trying to get it onto the hose, and we can now quickly, with a quarter-turn fastener, remove this and get on with our work at hand. And the beauty about something like this is that it saves a lot of time when you're at the racetrack.
A typical race program will start preparing about this time towards the beginning of fall every year, where we'll actually start modeling the new car. And so we'll be building up all of the tooling necessary for building the carbon fiber body parts off of. And then through the winter, we'll be actually building the components, fitting them to the car. And then after a slight lull in the action during the beginning part of the year, race season starts. And after race season starts and gets going, we have a lot of crash damage. We'll both repair and replace components throughout the season.
All the control devices and all the modular systems that we build is created by pen and paper first, and then we put it to PC, and then we evolve that into a full production item. Mainly after races that we generally analyze any problems that we've had at the track or any other development ideas that we have. Then we'll produce hardware then we'll install on the vehicle. And we usually have to do this in a matter of days.
One of the benefits of having this tool set is we are now applying that across all of GM's racing programs. So what we're learning in Corvette Racing is being used in NASCAR. It's being used in Grand Am. And what we're learning in NASCAR by applying these tools are making the Corvette Racing tool stronger. So that's really a major benefit, and that's why you see Chevrolet consistently the winningest name in racing, because we're applying these tools across all these arrays of racing, and it's been very successful for us.